unit is called PPTL. It stands for Parallel, Perpendicular, and Transversal Lines. So the very first thing we learned was we took two lines, we put what's called a what through those lines?
Transversal.
We put a transversal through those lines, and then we started naming angles. On day one, when we started learning those vocab words, these lines, A and B, those lines were not parallel. And if this symbol shows up on the test, let me show you what it looks like. A is not parallel to B. When we learned the vocab, the lines did not have to be parallel for the vocab to be true. Let's start going over some vocab. 5, 6, 7, 8. That'll do. I know this is on your review sheet as well, and there's more lines on your review sheet, which makes it even better, but let's just remind ourselves of some on here. Okay, what about 3 and 6?
Same side interior.
Same side interior. What about 1 and 7? Alternate exterior. What about 5 and 1? Corresponding. What about 2 and 4?
Vertical angles.
Vertical angles. And last one, 5 and 8. Linear pair. Okay, so what we did after that was we took all those words that we learned about, and then we changed our picture. Instead of it just being any two lines, we forced our lines to be parallel. How do I show that my lines are parallel? Arrows. Put some arrows on those two lines. So now the lines have been forced to be parallel, and now we have 5 theorems. Those theorems go something like this. If our lines are parallel, then what kind of angles are these? Then corresponding angles are congruent. If my lines are parallel, then what are these called? Same side interior angles are supplementary. But that only worked if they were parallel. So then we put all of our vocab words into 2 columns. Which ones went in the supplementary column? Same side interior went there. Same side exterior went there. And then from another unit, linear pair. Now, do you need parallel lines to have a linear pair? No. Supplementary? No. So be careful. You don't need parallel lines for that to happen. But you need parallel lines for these two to be supplementary. Okay, and then so what's left over for the congruent one? Alternate exterior angles. Of course, alternate interior angles. And what other one relies on parallel lines? Thank you, Trey. Corresponding. These are only congruent if we have parallel. And then the other one that does not need parallel lines, old unit, vertical angles. Don't need parallel lines for that. So, on the test, when you see one like this, I'm not really going to solve this. What do you do with those equations?
3x plus 2 plus 5 minus 9 equals
180.
Right, that's what we don't do is set them equal. What we don't do is set them equal. What we do, which sounds weird, is add them to equal 180 because of their name. Their name is same side interior angles, and same side interior angles are supplementary if the lines are parallel. If the lines are parallel. Okay. So then we got into a different part. We did converse. So then we said we maybe had 2 pairs of lines like this. And we said, let's call these A, B, and then C, D. And we said if angle 1 is congruent to angle 2, we said which lines are parallel. We didn't say are the lines parallel, yes or no. Which lines are parallel if 1 is congruent to 2? Yes. So we would say A is parallel to B. And how we know which 2 lines are involved is we cover up the line that is not needed. Which line do you not need to make angle 1 and angle 2? D. Nope, we need D. C. You're gone, C. You're out of my life. And so all that's left that would be parallel to each other are the A and the B. Now, what if you got one like this? And it said angle 3 is congruent to angle 4. Which 2 lines are parallel?
Neither.
Trey already knew it. like he stole the thunder. Okay, so if I said that angle 3 is congruent to angle 4, you would be tempted to say that C is parallel to D, right? Because those are the ones involved. You're involved, you're involved, you're involved. Okay, that's C and that's D. But you have to remember the lines, the angles, have to be doing what the theorem tells them to do. What kind of angles are those?
Same side interior.
Same side interior. Does the theorem say if two lines are parallel, then same side interior angles are congruent? No, because same side starts with an S, same side supplementary. So you have to be careful. They are not doing what the theorem tells them to do. So you don't write C is parallel to D, you write none. Could they be parallel? Yes, they could. But can we assume they're parallel? None.
No.
There's nothing we can assume are parallel. Okay, so when we were done with that, then we started to talk about slope. How do you find the slope of a line? The formula. What is the formula? Well, that's to write the equation of a line. Let's not even be fancy. Let's not even be fancy. Okay, so slope means subtract your y's. That's what delta means. Subtract is on your formula chart. Don't memorize it. Subtract your y's divided by subtract your x's. That's if you're given 2 coordinates. But what if you are given the graph of your line? What do?
Rise over.
You just count, right? I'm losing my voice, sorry. You just count. How many do I rise and how many do I run? And that becomes a fraction. It becomes your slope. So this one would have a slope of 3/7 for my made up numbers that I just made. Okay, so we talked about slopes. The next day, because we had talked about slopes, then we talked about parallel versus perpendicular slope. If two lines are parallel, what's true about their slopes? I just thought about this. Take a parallel symbol, take that symbol, and rotate it. What is that?
Equal.
It's an equal sign. And parallel lines have equal slopes. Whoa, mind blown, just thought about that. Okay, so parallel lines have equal slopes. What about perpendicular lines?
They have
What are their slopes?
9,
Opposite, reciprocal. Just opposite? No. Just reciprocal? No, it has to be both. Opposite, reciprocal. So that's what we learned the next day. The last day, we talked about writing the equation of a line, and that's what that last quiz was about, that little half sheet quiz. Now, sometimes you'll be given a slope and a y-intercept, and that's when you get excited, because what form do you go to? Y equals mx plus b, because you're given an m and you're given a b. But what most of my students struggle with is when they're given an m and they're given a point. And there's two ways. Yeah, go for it, Trey. Y minus the y1 equals,
X minus.
yeah, and that is on your formula chart. You don't have to memorize it.
That's
But you
right.
do need to know how to use it. So when you're given a point and a slope, this right here is not necessarily your y-intercept. So don't just use that as your y-intercept. You either need to plug it into point slope, or you can plug it into y equals mx plus b, but then you'll have to find the b, and then you'll have to put it back in.
Sorry, but in that slope intercept, right?
That's called slope intercept, and that's called point slope. Yes, ma'am, it is. Okay. And that was really where we ended, other than the very last day, which for my students was today because I was absent. We studied these guys. What is line L? Two things.
The midpoint, the midpoint.
Yeah. It's a perpendicular bisector, meaning it's going to hit my segment at 90 degrees, and it's going to do what to my segment? Cut it in half, divide it into
If you're parked in the
two.
back lot in the band practice
Con-
area, you need to move your car
No.
at this time.
Two
If you're parked in the back lot in the band
congruent
practice area, you need to move your
segments.
car.
Yeah, okay. Okay, guys, I feel like we didn't learn that lesson. So what you should have learned in that lesson is that you pick any point you feel like on line L. Let's pick this one. You pick any point you feel like on line L, and what did you learn about that point as it's related to A and B?
It has equidistant.
What was that fancy word?
Equidistant.
Equidistant. That point P, is equidistant from A and B. It makes a what kind of triangle? Yeah, it ends up making an isosceles triangle. Okay, so that's pretty much summing up what we learned. Now let's dive into the review sheet. All right, number 12 on the review. We'll do 11 and 12. Why not? I know for sure those are both on the test. Let's do it, 11 and 12. So on the test, you're allowed to use a highlighter. You're allowed to use a marker. You get those out if you need to. And you find your parallel lines and you either bold them, extend them, or highlight them.
Yes.
Do something to them. Okay. Now, in this picture, I have two transversals. Let's just look at one at a time. Let's look at this guy first. He looks like a fun transversal. What angle is alternate interior with that 20? Do you see the letter Z or an N actually? Name it.
I got 106
Y.
for the linear.
Y. Okay. So I already know that Y is 20. I've now solved one of my variables. Alternate interior angles. Alternate interior. Like the letter N or Z.
Put 13.
Okay. You don't have to do it this way, but I want to do it this way because I want you to learn your theorems. Here's your other transversal. This angle in Z. What is the vocab word for those two angles? Same side, exterior. Same side, exterior angles. That's our finesse. So they are supplementary. So to find Z, everyone's doing 180 minus 74. There's calculators back there if you need one. 106. Hey, Ronaldo.
Hi, Miss. How are you?
Great.
Good. I want to tell you something. What is the math office? Miss Copeland?
Right next door.
Next door?
Mhm.
Thank you.
You're welcome.
You look good.
We only have X left. That's it. How do you find X?
74 minus 20.
Okay, so that's an awesome way to look at it. I think Victoria was looking at, hey, this angle is corresponding with this angle. Corresponding congruent. So 74, 74, and she just did 74 minus 20. Another way to look at it would have been to use this straight line. How many degrees are in a straight line? 180, and then you could take away 106 and take away 20. Same thing, 54. Cool. X is 54. Now let's do 12 with kind of some of the same steps. DC is parallel to AB, so everyone marked it, right? You put an arrow on your picture already. Maybe you even bolded those lines or extended them. DG bisects ADF. I saw a lot of students work this problem, and they had not used this at all. They didn't even mark their picture. How do you mark bisect?
Oh, you make the two congruent.
You make two arcs like this. You can put tick marks on the arcs if you want, like one of your worksheets did, that parallel line diagrams. But arcs are how you show angles are congruent. That's how you show bisect. Bisect means cut in half. This angle has been cut in half, so it's two equal parts. There's one slice of pie left, you cut it in half, those two halves are equal to each other. Okay, the measure of EDF is 37. Find X, Y, and Z.
Again.
Did you find it?
Nobody's over there.
That's okay. All right, let's get back. Yeah, 37. What questions do we have about this angle being 37?
So,
We already marked them congruent. We know they're the same measure. 37, 37, but we haven't solved anything yet. Okay, let's do, I want to take care of Z first, actually. A lot of students didn't understand what Z was asking for.
What is Z?
Z is asking for all of angle A. That arc means I want the whole angle is what that arc means. So what I taught my students to do is when the picture gets too messy, go off to the side, redraw the same picture, and write down what you know. What is this angle? If I take it from here.
It is, I think,
37.
Times 2.
74.
Yes, that angle is 74. Now, we're looking for Z. What's the vocab word for 74 in Z?
Same side interior.
Same side interior, same side supplementary, same side supplementary. So 180 minus 74.
106.
We had that problem, that number in the last problem. So Z is 106. Now, I have the luxury of getting to erase, and I know you don't. but I'm just going to make it easier to be able to see. 37, and then we're going to do this right here. We're going to have some parallel lines and a transversal, and we can use alternate interior angles. So alternate interior. X is 37. How do we find Y? How do we find Y and don't say it's 37? It's the linear pair. It's the linear pair with X. 143. Awesome. So we used same side interior, we used alternate interior, and we used linear pair. 3 different concepts. We're looking at 13D. Use the diagram to determine if the statements are true or false. Do we have any lines in this diagram that are parallel?
Yes.
Which ones?
No, not that one.
No.
No, it doesn't say.
None of them. Okay. So right now, so far, nothing is parallel. So we're looking, this is our if, that's our hypothesis, and our conclusion. Okay. If angle 8, so I would like shade it or highlight it or look at it, equals 3 plus 4, then B is parallel to D. What's the vocab word for angle 8 and then 3 and 4 together? Same side, exterior. Those are same side, exterior angles. What does the theorem say they're supposed to be? Supplementary. Does that say, do you see a 180 there? No. They're supposed to be supplementary. They're not doing what they're supposed to be doing, so it does not force the lines to be parallel. So the reason it was false is because of what vocab word they ended up being. Okay, what next? You'll definitely have some like number 16 on the test. We're looking at 16B right now. What you want to make sure to do on the test is get them in slope-intercept form. Don't you dare try to determine the slope until they're in y equals form. So out of these two, are any of these in y equals form? Yeah, y equals negative 5x. What's the slope of that line? Negative 5. So let's just document that. I already know your slope. Your slope is negative 5. Now this other one is not in y equals form, but it's only going to take one step to get there. What's that one step? Minus 1/5 x from both sides. Y equals negative 1/5 x plus 8. What is the slope of that line? Negative 1/5. So we look at negative 1/5 and we look at negative 5. Are those opposite reciprocals?
Yes. No.
They are reciprocals, but they're not opposite. So the answer is neither. Now, if I would have been working too quickly and I just said, oh, 1/5 and negative 5, I would have put perpendicular and gotten it wrong. So make sure it's in y equals form to determine if they're parallel or perpendicular. What else? Yes.
I'll go back to 13.
Okay.
Yeah.
13A. Okay. So if angle 1 and angle 2, what is that really saying? If they add up to 180. If they're supplementary. Okay, so let's go look at our picture.
Oh wait, no, that was.
Not that one.
Wait. OC.
Those are let me just finish it off since I started.
Yes.
Those are corresponding angles. Corresponding angles are not supposed to be supplementary. They don't start with an S. So that's why A was false. But you want C. Okay, C. If angle 1 is congruent to angle 2, so we're going to write down the vocab word. There's angle 1. There's angle 2. Vocab word. Corresponding angles. Corresponding angles are supposed to be congruent. Are they doing what they're supposed to be doing? Now let's make sure they named the correct lines, because they might be saying 2 lines are parallel, but they might be naming the wrong lines. So what you do is you outline the angle and then make it longer. Connect this, then make this ray longer, and then make this ray longer. And now I can see what my 2 parallel lines are and what are their names. Then it kind of got moved. but it is line C and it is line E. So that's why that one is true.
But like, how would you know that it wasn't like B and D? Because like the
How I
angle-
know is that if I had white out, oh, could I get fancy? Let's see if it's gonna let me get fancy. Would that be white? Would be white. Okay. As I erase line B, is angle 1 still fully there? Yeah. That means B has nothing to do with the making of angle 1. Same with D. If I erase D, you are gone. Oh my goodness. Angle 2 is still perfectly there, so it's not B and D. They look parallel, I agree with you, but they have nothing to do with angles 1 and 2. So cover them up and see if those angles are still intact. If none of the angles get erased, then those can't be part of your answer. 26.
What team are you on? For football.
Write the equation of a line that is parallel to the line that passes through that, and then blah, 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 blah. Okay, where do we start? Start with an S. Everyone do it with me.
Oh, that's
26.
like delta y over delta
What do you do
x.
first? What is that called?
Delta y over delta x.
What's it called?
The slope formula.
Slope. Let's start by finding the slope. Very good. So I'm going to do y minus y divided by x minus x. Do not leave out a minus or a negative.
X plus 3.
That could be detrimental to the whole problem. 14 minus 4.
10 over negative.
Negative 8 minus negative 3. If you're scared of that, you are totally allowed to plug that into your calculator.
Negative 10 over 5.
Negative 5, okay. We never leave a slope looking like that. What is 10 divided by negative 5?
Negative 2.
Negative 2. That is the slope we were given.
Negative
Now I
2.
want everyone to circle this word, because it determines what we do with that slope. What do we do to the negative 2?
You
We're going
could
to
do
be
the y
parallel.
minus and then pick a point.
Okay, I wasn't there yet. You're on the next step.
Oh.
What do I do with this negative 2?
That's your slope.
Keep it. Do nothing. Very good. Okay, Trey, now I'm ready for what you wanted to say.
Well, if you want to find b,
You want to do it that way? Okay, we're going to do the y equals mx plus b way, but you can also do the point slope way. Which point do y'all want to use? Let's all use the same point.
Negative 3.
Negative and 5.
Oh, duh. We have to use this one. Okay. Y equals mx plus b. I'll stop right there for a second. Plugged in y, plugged in m, plugged in x.
Oh, I did not know
I thought that was the one you wanted me to use. It's just another way to do
We can
it.
use that one?
Yeah.
We can use any 3?
No, you can't use standard form to find the b. Don't use standard form unless you have to. What is negative 2 times negative 10? 20. 5 equals 20 plus b. Solve for b. Subtract 20 from both sides, not 15. Negative 15. So b is negative 15, and now we're ready to go. Y equals mx plus b. That's all there is to it. How did we start this problem? Slope. I think a lot of people just don't know where to start. And we took these 2 points and we started with slope. Okay, I was asked for number 15, so I'm going to do 15.
Oh, that's like.
It's what? 15 is what I just taught my students today. Everyone else learned it on Friday. Line L, which is this guy right here, is the perpendicular bisector of segment AB. What is the length of AC? So what you should have learned is that C is what from A and B? What's that fancy word?
Equidistant.
C is equidistant from A and B. So if C is 3 away from B, C is
Equidistant.
3 away from A as well.
I got b.
That's easy. Common sense. You could have done that one without the lesson, right? You would have picked 3 anyways. Which statement must be true? Not which statement could be true. Which one must be true, which is a better question to ask. Okay, let's check all these out. AD is congruent to BC.
No. come
Not
on now.
necessarily.
Come on.
AD is congruent to BD.
Yes.
Well, if it's a perpendicular bisector, what point does it have to pass through? It starts with M. It has to pass through the midpoint. What does that mean D is called?
The bisector.
It is a bisector and it is the midpoint. So if D is a midpoint, by definition of midpoint, AD has to be congruent to DB. So I think we're done, but we'll go over the other ones just in case. It has to be the midpoint, and the reason is because of this word right here. Bisect means that segment got cut in half.
Yep.
Half always equals half. BD equals BC? No. And last one, CD equals AD. Not necessarily. None of those made sense except for B. Okay, what next? It can be difficult since this picture can be very confusing with all the different lines going through it. But we want to zoom in on 2 and 13. So 2 and 13. So what we're covering up is this whole side here. Don't even look at it. Now, with 2 and 13, you ask yourself 2 questions. So we're only looking at these angles right here.
Same side.
Here's the transversal. So they are on the same side or alternate sides of that line. You already said it. Same side. Same side. Are they interior, which means interior,
No, ma'am.
or exterior?
Yes, ma'am.
They're exterior. So yeah, they're same side exterior.
I'm gonna keep the interior side.
Thank you for telling me. I'll have to change it on the key then. Cool. I can do that.
Which one?